Now let us discuss the next important characteristic or property of the fluid, that is viscosity. Next property is viscosity. This is an important concept in your fluid mechanics, so please pay attention to the concept of viscosity, that when viscosity will comes into picture and what do we mean by the term viscosity. So if I write the definition of viscosity, first of all just remember one thing, that this is a property of fluid. Viscosity is a property of fluid, but this is important, but its effect can be seen only when fluid is in motion. Only when the fluid is in motion. Viscosity is a property of a fluid, no doubt, but this property effect, viscosity, can be visualized, can be seen in a fluid only when the fluid is in motion. If the fluid is not in motion, the fluid is at rest, there is no concept of viscosity. You cannot say what is the viscosity at that point. You cannot see the viscosity effects when the fluid is at rest. So its effect can be seen only when then the fluid is in motion. And if I write the definition of the viscosity is the internal resisting force. Viscosity is the internal resisting force. It is an internal resisting force offered by one layer of fluid to the other layer when fluid is flowing. Just pay attention, when fluid is flowing and relative velocity between the layers exist. Right? So the viscosity is the internal resisting force. It is a resisting force offered by one layer to the other layer of fluid when the fluid is flowing and there is some relative velocity between these two layers exist. Relative velocity must be there. If the relative velocity is not there, then we can say that there is no viscosity between those two. There is no resisting force between those two fluid layers. Now let us discuss that why this is so, why this resisting force will come into picture. We will discuss it with the help of a diagram. Let us make a diagram here. Suppose, just for your understanding, we'll take this. Suppose this is if I draw here, suppose this is a solid surface over which fluid is flowing. This is a solid surface over which fluid is flowing, and I am saying this solid surface is at rest. This is a fixed solid surface. This is the starting point of the solid surface. This is the ending point. This is known as leading edge. This is known as trailing edge. We will discuss it. Let us say from this section the solid surface, solid boundary will start. Solid boundary will start. And over this solid surface the fluid is flowing. Over this solid surface the fluid is flowing. So these are the fluid layers over this solid surface which are flowing. Right? We are showing the fluid layers at some distance so that you have some better understanding. And there is a layer here which is in contact with the solid surface. This layer of fluid is in contact with the solid surface. Right? Now one thing you know already, that here exists a condition which is known as no slip condition. No slip condition means the velocity of this layer which is in contact with the solid surface will have the velocity same as that of solid surface. If this is at rest, then the velocity of this layer will be 0, and if it is moving with some velocity, let us say 10 meter per second, then the velocity of this layer will be 10 meter per second. Now if I say that, please pay attention. The fluid is flowing in this direction. This is the direction of flow. Let us say this is x. X is the direction of flow. Fluid is flowing in this direction, and this is the perpendicular direction to the direction of flow. Y is the direction which is perpendicular to the direction of flow. I am saying before coming in contact with this solid boundary, suppose the fluid is flowing here, also this fluid is there. If I am saying here also some fluid is there, this fluid is here also, then I am saying before coming in contact with this solid boundary, this fluid, each and every particle of this fluid, each and every layer of this fluid flow will be moving with some velocity which we known as u infinity. I am saying that if I show the velocity distribution before coming in contact with this boundary, then the velocity distribution will be like this. If this is a section, if I am taking this is a section, then if this is a small section I am taking, then at each and every point, at the velocity of each and every point will be same, and that is u infinity. It is same, u infinity. And u infinity is known as, there is a term known as free stream velocity. Free stream velocity. U infinity is free stream velocity. This distance is u infinity. This is the velocity distribution before coming to contact with this solid surface. Now when this fluid will come into contact with this solid surface, this layer, if I named it, let us say there are infinite number of layers are there, but for understanding we'll name it. Let us say this is layer 1, this is layer 2, this is layer 3, 4, 5, 6. I named it just for our understanding. Where I named it, first layer is which is in contact with the solid boundary, adjacent to it layer 2. These are adjacent to each other. We show some distance just for our understanding, but they are adjacent to each other. Then when this first layer is in contact with this solid boundary, it will take the velocity of this solid boundary. Now the velocity, if I say the velocity u of the first layer will be 0. Initially the velocity of the first layer here, let us say u infinity is 10 meter per second. Let us say we are assuming, let us say u infinity is 10 meter per second. So initially the velocity of layer 1 or the particle at layer 1 will be u1 initially will be 10 meter per second. After coming in contact with the solid boundary, the velocity will become 0. Now there are two types of forces. If we discuss here, there are two types of forces. First one is the cohesive forces. There are two types of forces: cohesive forces and adhesive forces. Cohesive and adhesive forces. Right? As the name suggests, cohesive. Cohesive forces means, cohesive forces are the intermolecular force of attraction. Cohesive forces means the intermolecular force of attraction between same molecules. between same molecules. Same molecule means if I say that we have water, then the intermolecular force of attraction between water molecule is cohesive forces between same molecules, and adhesive forces are your intermolecular forces of attraction. Intermolecular forces of attraction between different molecules. Between different molecules. Suppose different molecules means, suppose this is made up of iron, this boundary is made up of iron, and this is water. Then the forces of attraction between this water and this iron molecules is adhesive forces, and the forces between this water molecule is cohesive forces. That means the particles here, the fluid particles here are connected with each other with some cohesive forces of attraction, with some bond. Now let us suppose initially, if I will discuss only these two layers, layer 1 and layer 2, initially both the layers are moving with same velocity, 10 meter per second. But when this fluid will come into contact with this solid boundary, the layer 1 will become at zero velocity, will come to zero velocity. If I say the corresponding points on these two layers, suppose these 2 points, there are some forces of attraction between them, there is some bonds between them. As this layer 1 will retard to zero velocity from 10 meter per second to 0 meter per second, this layer of fluid, now this second layer of fluid will have some velocity, is there, because the no slip condition is only with this first layer. The second layer will have some velocity. So there is some relative velocity between these two layers. If I say this second layer will be having velocity 10 meter per second, the first layer will be having velocity 0 meter per second after coming into contact with this solid boundary, then there is some relative velocity of 10 meter per second exists between them. Then because of the cohesive forces of attraction, because of some bond between the same molecule, between these two molecules, then this layer 1 will apply a dragging force on this second layer in the opposite direction, and or you can say that like that, this first layer will try to decrease the velocity of this second layer. It will try to decrease some resistance. This first layer will provide some resistance to the moving of this second layer because of cohesive forces of attraction, right? So because of this cohesive forces of attraction, one resisting force will come into picture because there is some relative velocity between them. So this molecule will try to go in forward direction. If we can say, suppose these are the two molecules, initially they are moving parallel to each other, but after coming into contact, this molecule will be at zero velocity, but this molecule will try to move in forward direction. Because of some bond between them, because of some cohesive forces of attraction, this particle will try to drag this molecule, or will provide a resistance to the flow of this molecule, and this resistance comes because of this relative velocity, between them. So we can say that because of this internal resisting force which comes into picture, let us say the velocity of the second layer will be now 2 meter per second. The velocity will decrease to 2 meter per second. It will not be 0. It will decrease from 10 to, let us say, 2 meter per second. Right. Now, this velocity will decrease because some resistance force develop, because of some friction develop, because of some internal resisting force develop, and this internal resisting force or this phenomena is known as the viscosity. The property by which this frictional resistance force will happen here is known as viscosity, right? The viscosity will come into picture. You can see the viscosity. Because of this viscosity only, this internal resisting force will come into picture. Now if we talk about the second layer and the third layer, now the second layer is moving with velocity 2 meter per second. The third layer is moving with velocity 10 meter per second, and there is a relative velocity of 8 meter per second between them. Then this second layer will exert a frictional force, internal resisting force to the flow of the third layer, and it will try to decrease the velocity of the third layer, and will say that because of this the third layer velocity will decrease to, let us say, 5 meter per second. Now it will decrease to 5 meter per second. Similarly, there is a difference of 5 meter per second. It is moving with 4, it is moving with 5. Relative velocity of 5 meter per second is there. So one resistance force will be there on the layer 4, and I am saying, let us say the U4 will be 8 meter per second, let us say. And after subsequently there is a point, theoretically we can say there is a point where the velocity will become 10 meter per second. There is a point theoretically, but practically not possible. Theoretically we can say that the velocity of layer 5 is 10 meter per second, right? Because it is increasing 8 to 8.1, 8.2, 8.3 and so on. After some time it will reach to 10 meter per second. So the layer which is above the layer 5, any layer of fluid, the velocity will be 10 meter per second. Above this layer the velocity will be 10 meter per second only. So we can say that in this region from layer 5 to layer 1, in this region there is relative velocities, or you can say relative velocities are there, or you can say if I go from layer 1 to layer 5, we will see that at each and every layer the velocity is increasing, or with distance, if I measure the y from this solid boundary, then as y is increasing the velocity is increasing. That means velocity gradients are present. Velocity gradients are present. Here velocity gradients are present. Above this layer 5 there is no velocity gradient. Above this there is no velocity gradient. Velocity is uniform, that is 10 meter per second. So because of these velocity gradients, your velocity gradients are present, then because of this there comes the concept of viscosity. There comes the concept of viscosity. So viscosity will be there if there is a velocity gradient present, there is a relative velocity present between the different layers of fluid, and because of the cohesive forces of attraction, the internal resisting force is offered by the one layer to the other layer, and this property of offering the internal resistance force is known as viscosity. So that means the one thing is important for the viscosity is that fluid must be flowing. If there is no flow, there is no viscosity. And for flow, what is the prerequisite? Shear stress. So if there is no shear stress, there is no flow. If there is no flow, there is no viscosity. So the shear stress is most important to make a fluid to be flowing. So the fluid, if fluid is flowing, then there is some viscosity, some internal resisting force is developed because of these velocity gradients, and this property is known as viscosity.